Alright, you guys, so today's lesson we are going to be introduced to something called SOHCAHTOA. You may have heard of this term before, but this is sort of the basis of how we begin trigonometry. So in our previous lessons, we went over what a reference angle is, alright, and how to find the reference angle on the coordinate plane. And we also went over how to find the third side if we have a missing side of a right triangle. So we're going to put these two ideas together today to apply it to SOHCAHTOA. So what is SOHCAHTOA? You have three trig ratios. You might have heard of them before: sine, cosine, and tangent. So that's what these stand for. So these letters can be broken down into three parts. We have the SO, and this is sine. We have the CA, that's our cosine, and we also have TOA, which is our tangent. So let's talk about what they mean and how to use them. So we're going to start with SO. SO gives us how to determine sine value of a right triangle. So that is equal to, alright, sine theta. And remember, what is this symbol here? This theta that is inside here, it really is just our reference angle. So keep that in mind. It's like a variable x. You guys don't have to do much aside from know where it's at on the triangle. So that's going to be equal to the opposite, right, the O, over the H stands for the hypotenuse. Alright? And then let's move on. I'm going to try and keep this color-coded for you guys. We're going to move on to cosine. Cosine is going to be the CA. And that gives us cosine of the same angle. Remember, it's just our reference angle here, okay? Don't worry about that. Cosine is going to be equal to, if we use these letters, it's the adjacent. And you guys are probably wondering, what are all these words? What do they all mean? Well, we're going to go over that in a moment. So we have adjacent over, now what the H stand for? Hypotenuse. Alright, let's do our last one. Our last one will be TOA. What does TOA stand for? This is our tangent. So TOA is tan of the same reference angle. Alright, it's tangent of the same reference angle, which is equal to, the O now stands for this O, which is opposite, divided by, and in this case A. Let's recall what this A stands for. A stands for adjacent. So I'm going to tell you guys what these three mean, because that's the tricky part. SOHCAHTOA is easy once you can figure out three parts. You first have to figure out where the reference angle is, and then you also have to figure out which side is opposite, hypotenuse, or adjacent. So let's do that in this example here. So in this example, I'm going to show you guys how to do all three sides. So hypotenuse. We know the hypotenuse is always the longest side of the right triangle. So that's the easiest one to find. So let's label this side as the hypotenuse. And in this case, we don't know what the hypotenuse is. Let's move on and let's say, okay, so if this is our reference angle, this angle opens, I like to say it opens, right? It opens that way. If you look at the angle, it opens to this side. So whatever the side that is, so that will be our opposite side, because that's the side that it opens to. And then the side that you have left, which is adjacent, if you think about adjacent, that word technically means next to. So the angle, the side that is next to it, that's not the hypotenuse, will be our adjacent. Alright, so again, we have SOHCAHTOA, which stands for this. We have our right triangle. We know that all right triangles have a hypotenuse that we can label. And now we have to say, well, what is the opposite or the adjacent? the opposite is the side that the angle opens to, and the adjacent is the one that is right next to. That's not the hypotenuse. All right, so we have all the parts that we need. We have our theta, right, which is our reference angle. For each of these, that's all we need is opposite and hypotenuse. All right, so let's just take a moment, and we're going to go through all three of these for our SOHCAHTOA, this right triangle here. I'm going to keep it color coded for us. All right, so let me just make sure I have all my colors. All right, so let's take a look at sine. For sine, we need the opposite and the hypotenuse. So here is our example. Sine. All right, so where's our opposite? Our opposite is here, which is 3. So it's going to be 3 divided by, now the hypotenuse, right? We need to know the hypotenuse, but this is a big question mark. We don't know what the hypotenuse is, do we? So we have to take a moment to do the Pythagorean theorem to make sure we can figure out what the hypotenuse is. And luckily, this triangle is an example that you guys did in the last lesson. So we know, you could just take a look back, that this triangle, the hypotenuse is equal to 5. Now you guys can go out and do the whole entire Pythagorean theorem on the side if you need to, but I will tell you that once you do it, you'll get 5. So here for our sine, it's going to be 3 over 5. Okay? Now let's move on to cosine. What is our cosine? Our cosine example here will be, cosine is going to be the adjacent over the hypotenuse. So in this case, adjacent is 4. So it's going to be 4 divided by the hypotenuse. Again, we figured that out was 5. So it's going to be 4 divided by 5. We have one last one. One last one. Okay, and let's do tangent. So, tangent is now which sides are we going to use? We need to know the opposite and the adjacent side. So it's going to be 3 over 4. And what these are called trig ratios. Trig ratios. Let's remember that ratio, this word means fractions. All right, or proportions. So that's why you see them come up as fractions. So, first thing that we have to do is make sure we have all 3 sides of our triangle. If we have to use the Pythagorean theorem, we will use the Pythagorean theorem. We know where our reference angle is. So if your reference angle was over here, actually, I want you guys to keep in mind that if your reference angle was over here, then this will be your opposite side, right? I'm going to indicate that. So let's suppose, let's say, hold on, I'm going to get another color. Okay, so just to show you guys, I want to show you guys how, if your reference angle was over here, right? Let's say we're going to do this whole hypothetical example in orange, all right? So if this was your reference angle, remember, the opposite side is the side that the angle is open to. So this angle here opens to this side. So in this case, this will be our opposite side, and then this is the side that it's next to. So if your reference angle is if it's not in the same position, then your ratios are going to be different. Even in the same exact triangle, you're just going to have these numbers sort of switched around a little bit. So I want you guys to do the practice problem, and if you guys have any questions, feel free to email me or come to my office hours, and I'll be happy to help you. Yeah, have a good afternoon. Bye.